this is number 12 on page 526, and the question is, given this configuration, what is the, get a pin here, what is the net force on the 6 nanocoulomb charge? And so what we have to do here is there's a force between this, see these are all positive, so the 2 nanocoulomb down here is going to be pushing away like that, right? And then the 3 nanocoulomb is going to be pushing away like that. And what we have to determine is what's the distance r from there to there, what's the distance r from there to there, and then do use Newton's, not Newton's, sorry, the electric force equation, which is K Q1 Q2 over R squared. We're going to use it twice. And so, and if we just, what is that, 5 squared plus 5 squared square root, so square root of 50. So the distance between both of those is going to be 7.07. But since everything's the same, it'll be a 45-degree angle also. So I'm going to say that we're going to call this F1. We're going to call this F2. So F1 is going to be 9E9. Actually, you know what? Let me do it down here so I F1 is going to equal 9E9 newtons meters squared per coulomb squared times 3e to the negative ninth coulombs times 6e to the negative ninth coulombs all over the distance, which I think we said was 7.07 meters, and we got to remember to square that. And we get a number, right? So I'll put it in my calculator real quick. 9 second E9 times 3 second E negative 9 times 6 second E negative 9 divided by 7.07 squared. I get, if the calculator gives me the right number, I put it all in correctly. It's 3.2 E to the negative ninth newtons. In other words, 3.2 times 10 to the negative ninth newtons. It seems kind of small to me. Let me redo that and put some parentheses. Be sure. Nope, that was right. So F1 is going to equal 3.2 times 10 to the negative ninth newtons, all right? F2, we're going to do the same thing, 9E9. I've already put the units up there, so we'll just put the numbers in. This would be 2e to the negative ninth, 6e to the negative ninth, and this is all going to be over 7.07 meters squared. Now, if you put it on your calculator the way I did, you just hit second enter and go up and change the 3 to 2, and everything else is the same, and I get 2.2. This one's going to be 2.2 times 10 to the negative ninth newtons. That's F2. So what do we do now? The net force on that is going to be up the middle someplace, correct? The net force is going to be up the middle like that. Let's see here. I think this is going to be a 45-degree angle, I believe. And I believe this is going to be a 45-degree angle. So all we have to do is find the x and the y values. Now, there's going to be two x's and and there's going to be two y's, and the y's are going to cancel out. Well, actually, they probably won't because they aren't the same. But basically, you're going to, let's see, let's put our numbers here. This one is 3.2 nanonewtons. And this one is 2.2 nanonewtons. 2.2 nanonewtons. And so if this is my hypotenuse, I know the angle, then cosine is going to be the blue and sine is going to be the y. Cosine is going to be the blue, sine is going to be the y. Add all your x's, add your two x's, subtract your two y's, and that'll get